Hello, this is a video on how to log in and run the demonstration of Coriolis2. Now, I must apologise. This is a remote server, so you, you have to bear in mind that it is a terminal and an SSH terminal, so connectivity is there is a latency in the response. Okay, and because what we're going to be doing is we're actually going to producing graphical files, GDS-II files. You either have to choose whether to download those files, which will involve SCP, secure copy, or it will involve actually running it remotely. If you run it remotely, just bear in mind that because you're tunneling an X11 protocol over SSH, it's going to be very slow. All right. So the first thing, if you want to do this graphically, very slowly, you must have a Linux system, or if you have a Mac, you must have installed the X11 subsystem first. Okay, so assuming that we have a Linux system, it doesn't matter what it is, it just has to have Windows X Server installed. The first command that you must do is you must type xhost plus in your local terminal. Okay, and you should see that message: access control disabled, clients can connect from any host. All right. Now, if you don't see that, then you need to reconfigure your X11 system so that it will allow TCP IP connections in your X11 config. Right, and that I believe on Debian is it says etra x11/xorg grep TCP etra x11/star xserver SC, so vi etc x11 xinit xserver rc, and you must have this option -listen TCP. Okay, all right, and then the xhost plus and this procedure that we're going to be doing will work. All right, so the first thing that you have to do is you log in as a student. So it is SSH -X. That enables X11 forwarding. That is critically important. Student 25 at cerberus.nic.uoregon.edu. All right. So we've done the -X. Welcome to the NICPRL, and the password, which I'm not going to tell you what that is publicly. And I'm not going to type it out of my head. Good, I got it right. Your second step is you must do the same SSH -X to the Silicon server. All right. Now, pre-prepared for you are there's an alias check toolkit. Okay, so we're going to do we're going to run the adder benchmark. So, but the first thing you do is you must enable the environment which sets up all the libraries and so on. So source./coriolis-env. Okay, ta-da! Switching to Coriolis2. Now that's shared in the home Coriolis2 directory, but basically we've pre-compiled everything for you, so you don't have to build everything for the purposes of this tutorial. Now we're going to change into the alias check toolkit. Leon's check toolkit directory, ls. We're going to check cd into the benches, which is the benchmarks, ls. You can see the adder one. You can run any of these if you like. You can explore it later if you really want to. Adder, cd adder. Alright, ls. And we're going to change into the CMOS directory. Okay, ls. Alright, so here's the things. Now we're going to clear out what the previous student did with make clean. Okay, alright, so that's now a clean start. To make the GDS-II file is very, very simple. Make LVX. And because this is such a ridiculously fast and very quick machine, it's done almost in a few seconds. Alright. And there we should see chip R. I think was a chip R ring.gds. What we're also going to do is make yes, brilliant. So make GDS will create the GDS file for you. Now, at this point, if you don't have a suitable graphical machine, you can copy that file off to your local machine and you can run a local GDS-II viewer, or after suitable virus checking you can run an online one, right? But it is your personal risk if you do that. Okay, so first thing is this chipr.gds file. Okay, copy chip_r.gds home directory, that's tilde. Okay, alright, ls-al tilde in the home directory, and we should see in the home directory that there is the chipr.gds file. Now you go back to your local machine, okay, and you type this command, scp the student login student 25 at uoregon. What was it again? Excuse me, will I just have a look off screen? config cerberus.nic.uoregon. So sorry, cerberus.nic.uoregon.edu chip_r.gds to the local, to the current working directory, so dot. So that's scp student 25 or 212345 at cerberus.nic.uoregon.edu chip_r.gds space dot, and it will ask for the password eventually. Oh, it's got SSH agent forwarding. Oh no, there we go. Trying not to spell the password out in my head. And depending on your network connectivity, that's going to be horrendously slow or horrendously fast. If you're really lucky, it will be nice and fast. Now you need to go to another window or thing, or wherever it is that you have, for example, klayout installed. I have klayout installed on here, thing. So I'm going to copy that chip_r.gds to where I know that the my computer can get at it. All right, on that sort of thing. /klayout. That's klayout is started up here. file open /temp chip RDDS. Ta-da! Alright, and then you can have, drill down. There's the corona, there's the chip, that's the corona, that's the adder, and that's what the various cells in it, and you've got the usual layer stacking, etc., etc. Now, klayout does actually have the option to do DRC rule checking. That tip was given to me very kindly by Mohammed Qassem of eFabless. You'll have to look up where that is and how to do it, but I do know that it is actually possible to run DRC rule checking scripts from klayout, which is absolutely fantastic because it's entirely Libre licensed DRC checking. Alright, so that's if you copied it locally. You have to build it, make LVX, make in here back on the server, make LVX, make GDS, then go to this other then copy the file into the local directory. That's the history of the commands that we've done. Alright, so you can pause the video at this point and have a look at the list of commands. Okay. Which is there, those ones. Alright. Now, if you want to do this remotely, please bear in mind this is going to be horribly slow. We're running X11 forwarding over a remote internet connection that in your case will be 10,000 miles away, so it's going to be very slow, right? You just do make CGT, right? Now we wait. Alright, so it's now preparing the graphical setup, and over my internet connection, which is a mobile broadband one, it is currently very slowly setting up the sending the X11 commands over SSH from Silicon to SSH to Cerberus, over SSH back to my local machine. Here we go. All right. Now, here you have to be very patient, and you have to watch what the cursor does. Okay. Now the cursor has gone large, so that means that it is in if I type any keyboard or do any mouse movements in here, it is sent to the server, the command running remotely on the server. So I'm going to type Control O. I'm not going to use the menu, the file open menu, because it will be way too slow. So I'm going to do Control O now. And you can see I did that 5 seconds ago. 10 seconds ago, it's still doing absolutely nothing. Oh, finally, we're getting an open cell dialog box. Okay. Now I'm going to move the cursor into this box, and we're going to wait for the dialog to get itself sorted out. Now, it's critically important at this point that you move the cursor into the white typing dialog box, and then wait for the cursor to change. Alright, so I'm going to deliberately click on it. The cursor should change. There we go, the cursor has now changed. Now we can type the name of the cell that we want to open, which is chip_R. CHIP_R. You can see the delay immediately. I mean, it's a 2-second delay on that, just on doing that. Okay, and now we're going to press return. Okay, ready? Return. This is very specific. You have to click on that box, the white area, and wait for the cursor to change. And wow, there you go. That's the exact same a cell layout as in the it's in klayout. So now it's viewing the GDS-II files remotely for you, fired back at your local X11, your local X11 server, and that's why it's so very slow. So you're better off SCPing the GDS-II file to your local machine and viewing it locally with klayout or other free software tool, or if your university has some GDS-II viewers available for you to use, then you use those. But actually, it would be, it's up to you. All right, down to you and your responsibility. All right, so that's basically it. Thank you very much.